We often hear that the age of the universe is approximately 13.8 billion years. Logically, light, no matter how fast, could only travel that many light years in that time. If light began its journey at the exact moment of the Big Bang, then today the furthest radius we could see should only be 13.8 billion light-years. Double that and the diameter of the observable universe should be roughly 27.6 billion light-years. It sounds perfectly logical and perfect. However, in textbooks you'll find a number that shocks us all. The diameter of the observable universe isn't 27.6 billion, but roughly 93 billion light-years. More than 3 times the initial calculation. A question immediately arises. Where did the other 65 billion light-years come from? Did light travel faster than the allowed limit? Or is something deeper happening within the fabric of space and time that our intuition cannot grasp? Where did those extra 65 billion light-years actually come from? Was light mistaken, or is the cosmic speed limit silently collapsing? Or is the universe playing a joke on us? The truth is more fascinating than any theory. In today's video, we will unveil the mystery of this apparent paradox. This isn't just a story of huge numbers, but the key to understanding the nature of space. How the universe works, and why human intuition is so easily deceived. We calculated 27.6 billion because our brains are misled by daily experience. We live in a world where space seems absolutely static. The ground doesn't stretch, rooms don't grow, and the sky doesn't lengthen. Subconsciously, we apply that premise to the entire universe. We see the universe as a fixed stage, with galaxies as actors moving upon it. But this harmless-looking assumption leads to a wrong conclusion. Because space is not an immobile backdrop. The stage itself is expanding and directly participating in the grand play. If you imagine the Big Bang as a grenade exploding on the ground, your reasoning would be perfectly sound. Fragments, no matter how fast, cannot exceed the speed of light. So after 13.8 billion years, they shouldn't be further than 13.8 billion light-years away. This logic is tight and familiar, but reality is different. The Big Bang was not an explosion in the conventional sense. It defies intuition. No center of explosion, no matter blasted into existing space. The Big Bang is the violent expansion of space itself. Space isn't a static stage, it is the main character. Imagine you draw galaxies on the surface of a balloon. When the balloon isn't inflated, the galaxies stay still. But as the balloon is blown up, the distance between them grows rapidly. This is because the surface of the balloon is stretching. Galaxies aren't racing away at superluminal speeds. As long as space expands, distances can grow faster than any intuition allows. This mechanism is the key to understanding the Big Bang. This is the heart of Einstein's general relativity. Space is a dynamic entity that can be bent, pulled, and expanded over time. With this, 93 billion light-years is no longer a paradox, but a necessity. It is the result of an incredibly lopsided race. One side is light, the fastest runner in the universe. The other is space itself, constantly lengthening the path light must cross. Turn back the clock over 13 billion years. Suppose a young galaxy emits light toward a future Earth. At that time, the universe was very small. It was actually only 42 million light-years away from our position. The problem lies in the expansion. Light travels for a year, getting 1 light-year closer in theory. But in that year, the space between it and Earth has stretched. This is like running on a treadmill. While you run forward, the belt beneath you moves backward. In the early universe, expansion was massive, many times the speed of light. Light flies toward us but gets further away from Earth. Because space ahead of it is created faster than its own travel speed. However, the universe doesn't expand at that crazy rate forever. Over time, the expansion rate gradually slowed down. Eventually, the persistent light began to win, closing the gap with Earth. After a journey of 13.8 billion years, it reached our eyes. That light truly traveled for 13.8 billion years. But where is the galaxy that emitted it now? In those 13.8 billion years, the galaxy did not stand still. It was carried away by the stretch of space in the opposite direction. The further it got, the more space stretched between us. Light moves forward while the galaxy is pulled back by space. We see ancient light while the galaxy itself is now much further away. When we catch that image sent 13 billion years ago, the object itself has not been at that location for a very long time. Expansion has pushed it to a place 46.5 billion light-years away. This is called the Comoving distance. The actual distance between us and that galaxy at this moment. If we froze expansion right now to measure, the furthest source would be at the 46.5 billion light-year boundary. A radius of 46.5 billion makes a diameter of 93 billion light-years. This leads to a very confusing truth. 93 billion light-years is not the distance light has traveled. Light only actually traveled for 13.8 billion years. 93 billion is the current location of the object that emitted it. We see the past, while its present is in a place beyond intuition. Expansion is faster than light, but Einstein said light is the limit. Was Einstein wrong? The answer is no. His laws apply to matter moving within a reference frame. You cannot fly a ship through space faster than light. But the expansion of space itself doesn't fall under this rule. Space is not matter, nor does it carry information. Expansion is a change of coordinates, not movement through them. Hubble's law: the greater the distance, the faster the recession. Beyond a certain point, galaxies recede from us faster than light. The oldest galaxies we see are now receding at superluminal speeds. The observable universe is just the limit of our cosmic bubble. Beyond this boundary, countless galaxies and stars surely exist. But their light will never reach Earth because of the distance and expansion. This suggests the total universe could be infinite. Even if not infinite, it's far larger than 93 billion light-years. Could be hundreds of times larger than what we can observe. We are like observers trapped on a small boat in a vast ocean. Our telescopes can only see to the horizon. We think it's the end, but a massive ocean remains beyond. Understanding this reveals a bittersweet truth. The universe is expanding at an accelerating rate. Galaxies at the edge are accelerating away from us. If humans still exist in trillions of years, the night sky will be a completely different scene. Distant galaxies will vanish as if they never existed. The sky will be quiet, with only a few lonely stars. Our descendants will never know how brilliant it once was. This makes the present priceless. We live in the rare era when the universe can still tell its story. That's all for today. Thank you for watching.